Hello everyone, and welcome to another math tutorial video. This time we will be simplifying expressions involving rational exponents. And this is the first of the two. So this is IXL M5 if you're interested, and we're going to be doing 16 to the 8/5 times 2 to the 8/5. And honestly, y'all, this is kind of like IXL M2. So it really is pretty similar. So anyway, it's going to be probably a little bit harder though. So we have the same exponent, but we have different base. So kind of going back to the same rules we did in M2, we're going to just group them. So we're going to do 16 times 2 because they both have the same exponent, and then they're both to the exponent of 8/5. So 16 times 2 is 32. So we're going to have 32 to the 8/5. Now, kind of, if I wanted to do this in my head because I'm crazy, I know that 32 to the 1/5 is 2. So then basically I'm doing 2 to the 8th, which would be let's see, 2 to the 5th is 32, 2 to the 6th, 64, 2 to the 7th, 128, 2 to the 8th is 256. So, but if you weren't sure about that, remember, if you were going to type this in the calculator, you would type it in as 32, and then you would use your exponent button. And then since I'm doing a fractional power, I do 8 divided by 5. But let's do that to verify ourselves. So 32 to the 8/5. And indeed, I get 256. Okay. So really not that bad, was it? Pretty similar to what we've already done. So let's try another one. It's a little bit harder. Okay, so on this one, we got 8 to the 1/6 times 8 to the 1/6. Well, same base and same exponent, but since I have the same base, we're going to use that rule of adding exponents since I'm multiplying. So this is going to be 8 to the 1/6 plus 1/6. And these fractions have the same denominator, so that's just going to be 8 to the 2/6, which means 8 to the 1/3, because 2 and 6 both divide by 2, and so it gives me 1/3. And, well, 8 to the 1/3, 8 is a perfect cube, and that basically means the cube root of 8, which is 2. So that's really all we can do on that one. So let's try one with negative exponents. So on this one, we have 8 to the negative 7/4. I hope that looks okay. And then we're multiplying that by 2 to the negative 7/4. So we have our exponent, which is the same, but our bases are not the same. So we're going to do like we just did in the first example, and we're going to group them. So we're going to have 8 times 2, and our exponent is negative 7/4. So that's going to equal 16 to the negative 7/4. But we got a negative exponent. We're going to have to fix that. So if I have a negative exponent, I want it to be a positive exponent. So we're going to simply move it to the bottom. So we're going to have 1/16 to the positive 7/4. And, again, I'm kind of moving fast because this is similar to what we did in IXL M2. So if I just typed in 16 to the 7/4, I get 128. Okay. So really not that bad, was it? So let's do some algebra. Let's throw some variables in here. So if I have y to the 17/6, well, that's a beautiful fraction, isn't it? So y to the 17/6, we're going to multiply that by, or at least, yeah, this stylus. Okay, we're going to multiply that by y to the -5/6. Alrighty, so on this one, same base. So if I have the same base, we add exponents. So our base is y, so we're just going to bring our base down, y. And then we're doing a 17/6, and we're going to be adding the -5/6. So essentially that plus doesn't do anything. I'm doing 17/6 minus 5/6, which is 12/6. So y to the 12/6. But we can simplify that. 12 divided by 6 is 2. So it's going to be y to the second power. Or y squared. Okay, not bad at all, is it? Okay, let's do another one. So let's do another one with variables. So let's spice it up a bit. Let's throw 3 of these in here. So say I have u to the 9/7 times u to the 8/7 times u to the hold on, yeah, 6/7. And it just so happened that all of these had a common denominator, so that makes our life a little bit easier. Since even though I have 3 of these, it really doesn't matter how many you have. If they have the same base, you're just going to add your exponents. So basically we're going to be doing u, and then our exponents, I'm going to just add those up. So we're going to do 9 man, work with me, come on. So u to the 9/7 plus 8/7 plus 6/7. Because, can highlight that. Add those up. So when I do that, so 9/7, 9 plus 8 is 17. 17 plus 6 is 23. So they all had a common denominator. It made our lives quite a bit easier. So we're going to have u to the 23/7. And, well, that's really all we can do because 23/7, 23 and 7 don't have a common factor. So I can't really simplify that any. All right, one more example. So on this one, let's take s to the 3/2 divided by, hold on, I don't want to use s. Use a different variable. Let's do it as m to the 3/2. Divide that by m to the -1/2 divided by m to the 3/2. Oh my heavens. Alright. Get it eventually. Okay, so this one looks really intimidating. But don't let it get you down. So don't even worry about, remember, don't worry about the left yet. We're going to follow our order of operations. Yep, remember, please excuse my Darren Sally, all the good stuff, however you remember it. So we're just going to keep m to the 3/2 on the left. We're not doing anything with that yet. But we're going to solve this parenthesis. So we're going to do it first. So I'm going to rewrite this as m to the negative 1/2 over m to the 3/2. And whoa, I had a bit of a mess there. Okay, so let's simplify that. So just like we've done in the last, if I'm dividing and I have the same base, what do I do with the exponents? I subtract the exponents. So my biggest one is on the bottom. So it means I'm going to subtract these. So we're going to have m to the 3/2, and then we're dividing that by, okay, so my m's are going to cancel on the top, so it's just going to be 1 over, because my biggest one's on the bottom. So I'm going to do m to the 3/2 minus negative 1/2. Kind of crazy, ain't it? So that's going to be m to the 3/2. I'm still not doing anything there. Divided by 1 over m. Okay, 3/2 minus negative 1/2. That means 3/2 plus 1/2, which is 4/2. So m to the 4/2. So this is going to be m to the 3/2 divided by 1 over m squared. Okay, you may be like, oh my heavens, we're still not done with this. Okay, well, we're almost done. Okay, so this one brings back another skill from a long time ago. If I'm dividing fractions, so remember the alternative of dividing fractions, or a good way to make it easier to divide fractions, is to simply multiply by the reciprocal. So when I go over here, we're going to have m to the 3/2. If I could write that, be nice. So m to the 3/2, and we're going to multiply by m to the 2nd over 1. Basically, I'm just multiplying by m to the 2nd. So I don't really even need that 1, but I'm not leaving anything out. So m to the 3/2 times m to the 2nd. So I'm multiplying the same base, so I'm going to add my exponents. So let's do that. So we're going to add 3/2 and 2. So we're going to have m to the 3/2 plus 2. Okay, so that's going to be m, and you can always use a calculator to make this easier on yourself, but 2 is the same as 4/2, so 3/2 plus 4/2. So my final answer is going to be m to the 7/2. And that is it. And I think that is probably enough for this. You won't have a problem like this one unless you get really, really high up, kind of as an extra challenge. So hope you found this video helpful, and